Hello students, in this video we are going to discuss about isomerism. Let us define what is isomerism. The phenomenon of existence of two or more compounds possessing the same molecular formula but different properties is known as isomerism, and such compounds are called as isomers. That means if the compound which having the same molecular formula, if two compounds are there and both have same molecular formula, that means number of carbon hydrogen are same in that, but they possesses different properties, and these properties can be physical and chemical. In such compounds which have same molecular formula but different properties, these compounds are called as isomers, and such phenomena is called as isomerism. Let us classify the isomerism into two types, that is structural isomerism and stereoisomerism. In structural isomerism, there are following type of isomerism. From this we have to study chain isomerism, positional isomerism, functional and metamerism. These two are not for our syllabus. And in the stereoisomerism, there is geometric isomerism and optical isomerism. So these two will be discussing in the next chapter. So here we have to discuss the fourth type of isomerism, that is the structural isomerism, in which we have to discuss about chain isomerism, position isomerism, functional isomerism and metamerism. So let us discuss these type of isomerism in detail with example. First one, chain isomerism. When two or more compounds have similar molecular formula but different carbon skeletons, these are referred to be a chain isomers, and the phenomenon is called as chain isomerism. Let us take one example, then it will be clear. Let us take the 5 carbon hydrocarbon, that is pentane. Here, let us count the number of carbon here. It's a 5 carbon compound, and here the number of hydrogen, when you count it here, it is equal to 12. That means a pentane having 5 carbon and 12 hydrogen. Let us branch this one in this way. Now, when we branch it, when we count it, the number of carbon here, because 1, 2, 3, 4, 5 carbon, and when you count the number of hydrogen, that is 12. So here, when you compare these two structures, they have same molecular formula. That means the molecular formula, that means that it have same number of atoms. That is, it have 5 number of carbon atom and it has 12 number of hydrogen. Both having same molecular formula. But we can't call it as the same one, because here when you find it out the main chain, this one is the main chain or the parent chain we can say, and here the parent chain is this one. Count the number of carbon atom in the parent chain, that is, when we count it here in the first case, because here number of carbon atom in the main chain is 5, and here the number of carbon atom in the main chain is 4. That means there is a difference in the, we can call it as there is a difference in the carbon skeletons, or we can say there is a different number of carbon atom in the main chain. That's why it is called as chain isomerism. Why it is called as a chain isomerism? Because there is difference in the number of carbon atom in the main chain. That is why it is called as chain isomerism. And definitely these, even though have same number of carbon and hydrogen, that means they have same molecular formula, but still they differs in the properties. That is both in the physical and chemical properties. So such type of compounds, that is these two compounds, are called as isomers. Again, there is one possibility. If we make the structure here, now you can find it out here. The number of carbon atom is same and number of hydrogen is also same. But what is the difference here? That is the difference in the number of carbon in the main chain. Here, this is the main chain. In this case, this one is the main chain, and here this one is the main chain. So the difference in the carbon number in the main chain, here is 5 number of carbon in the main chain, here it is 4, and here it is 3 carbon in the main chain. And definitely these shows different physical and chemical properties. Even though have same carbon numbers and hydrogen numbers, but they shows difference in the physical and chemical properties. So this type of isomers are called as chain isomers. These are the chain isomers. Next is the position isomerism. When two or more compounds differ in the position of substitute group or the functional group on the carbon skeleton, they are called as position isomers, and this phenomenon is called as position isomerism. As the name says, position, that means if there is a difference in the position. Now let us take one example here, that is a propane 1-ol. Now we can take one more formula here, that is propane 2-ol. Now look at here, what is the difference here? When you count the number of carbon, that is here, the carbon number 1, 2, 3 is the carbon number. And what about the hydrogen number? Hydrogen number here it is 3 plus 2, 5, 6, 7, 8. 8 is the hydrogen number and oxygen number is 1. Similarly, when you count in this second structure, 3 number of carbon and hydrogen number 3 plus 3, 6, 7, 8 and 1 oxygen. So total the carbon number is 3, hydrogen number 8 and the oxygen number is 1. So they have same molecular formula. But what about the difference here? When you look at here, the difference is actually the position of a functional group OH. That means here when you select the main chain, that is I am selecting the main chain here, which we have learnt while naming. This is the main chain. Now when you find it out here, in both the cases main chain have 3 carbon. So we can't call it as chain isomerism because the carbon skeleton or the main chain have same number of carbon. But what is the difference here? Difference is in the position of OH group. That is OH group in the first case, this is the first carbon, this is second, this is third. So OH is on the first carbon. But in the second case, OH is on the second carbon of the main chain. So that is what the difference here, that is the position of a OH group is different. So the name position isomerism is used because there is a difference in the position of the substitute group, or we can say any functional group. If there is a difference in the position in the main chain, then it is called as position isomerism. Next type of isomerism, that is functional group isomerism. Two or more compounds having same molecular formula but different functional groups are called as functional isomers. That means two or more compound which have same molecular formula. Then we find out the number of carbon, hydrogen or oxygen, whatever it is there. They have same number of that different atoms present in it. But what is the difference in that? That is the difference in the functional group. So definitely the properties get changed completely because there is a different functional group. So this type of compounds are called as functional isomers, and this phenomenon is called as functional group isomerism. Let us take one example, that is propanol. Propanol is having 3 number of carbon, that is C3, and it have 6 hydrogen and 1 oxygen. Let us take the isomer for this compound, that is propanol. Now why these are called as isomers? So that is actually because these have same molecular formula. When you count the number of carbon, in this it is 3 carbon. In the case of propanol, there is 3 carbon. But what about the number of hydrogen? The number of hydrogen, it is 3 plus 3 is 6 here, and here also 3 plus 2 5, and 1 hydrogen here 6. So same number of carbon, that is C3, same number of hydrogen, that is 6, and there is one single oxygen here, and here also it have a single oxygen. So what is actually, why these are called as isomers? Because they have same molecular formula, but they have different physical and chemical properties. Why they have different physical and chemical properties? Definitely because these two have different functional group. That is, here there is a ketonic functional group, and here there is a aldehyde functional group. So because these functional groups get differ, that's why the properties of these two compounds are entirely different. Because one is the ketone, this one is the ketone, and the other one is an aldehyde. So definitely they have different properties, that is both physical and chemical properties are different, but they have same number of carbon, hydrogen and oxygen. That means they have same molecular formula. Therefore these two are called as isomers. And why these are called as functional group isomers? Because there is a difference in the functional group that is highlighted here. So that compounds are called as functional group isomers, and this phenomenon is called as functional group isomerism. The next one is metamerism. It is due to the different alkyl chains on the either side of the functional group in the molecule. Let us take the example, that is methoxypropane. The formula is CH3O C3H7. That means when you look at here in these two examples, both having the same category of the compound, that is both are ethers. But what is the difference here? When you look at on the either side of the functional group, that is here 3 carbon, that means CH3 is there, it's CH3 and it is C3H7. When you look at on the both the side, but here in this side C2H5, on the other side C2H5. So that is what the metamerism is due to the different alkyl chains on the either side of functional group. That means in this the functional group is O. So check on both the side. Here it is C3H7 and it is CH3 and the other one is C3H7. But here it is C2H5, C2H5. So that is the alkyl chains are differ on the both the side of the functional group. That's why it is called as isomers, and they have same molecular formula. When you check the number of carbon here, it is 4, and here also C2, 4 carbon, 1 oxygen, and when you count the number of hydrogen, it is also same. So what is the difference here? The difference in the alkyl group on the either side of the functional group is different. That's why it is called as isomer, and especially this isomer is called as metamerism. Next we have stereoisomerism. The compounds that have same constitution and the sequence of covalent bonds but differ in the relative position of their atoms or groups in the space. That means they have same molecular formula, same sequence of covalent bond, but what is the difference here? The position, relative position of atom or group of atom in the space, in that is surround to the double bond or the single bond, how these are arranged, that in that particular space, that is different, and that is what called as stereoisomers. So this isomerism will be discussing, that is two type of isomerism, geometrical and optical isomerism. We will discuss in the next further videos in the next chapter. So this is all about this video. Have a nice day.